To simplify these equations, number 11, we got tangent of x times cosecant of x divided by secant of x. Tangent of x is the same as sine over cosine. Cosecant is the same as 1 over sine, and secant is the same as 1 over cosine. Those are a quotient identity followed by two reciprocal identities. The sine in the numerator and the sine in the denominator of the numerator cancel. So this is 1 over cosine of x divided by 1 over cosine of x. Anything divided by itself is 1. Or you could rewrite it as 1 divided by cosine of x times, instead of divided by, cosine of x over 1. In other words, dividing by a fraction is the same as multiplying by its reciprocal. Cosines cancel, and you get 1. Number 12, tangent of a times cosine squared of a. Tangent can be written as sine of a over cosine of a. You can cancel a cosine from the top and the bottom, and you get sine of a times cosine of a. Number 13, if you write tangent of b, leave it the same and change divided by the fraction bar to divided by symbol, cotangent of b. It's the same thing as the original, just written differently. Cotangent of b, instead of dividing by it, you could write it as times 1 divided by cotangent of b. It's the reciprocal identity. 1 divided by cotangent of b is the same thing as tangent of b. Something times itself means it's squared, so you get tangent squared of b. We got two fractions we're subtracting. They have common denominators, so combine them. You get 1 minus cosine squared of theta over sine squared of theta. A little side work here. Sine squared of theta plus cosine squared of theta is 1. If you get sine squared by itself, you get sine squared is 1 minus cosine squared of theta. Notice that's the same thing that's in the numerator. That's in red. So you can replace the numerator with sine squared of theta. Anything divided by itself is 1. 15, using the Pythagorean identity, 1 plus cotangent squared of beta is cosecant squared of beta. On the top, you got cosecant of beta. On the bottom, you get cosecant squared. So cosecant cancels on the top and the bottom. Quotient identity, 1 divided by cosecant squared. 1 divided by cosecant of beta is sine of beta. 16, we have a product here. You can multiply the 1 times the 1 and get 1 squared, which is 1. You're going to multiply negative sine of x times 1. You're going to multiply 1 times positive sine of x. So your middle two terms, negative sine of x and 1 sine of x, cancel. And then multiply negative sine of x times positive sine of x, you get negative sine squared of x. It's just a FOIL method. Some side work again, uses the first Pythagorean identity. You'll see that cosine squared is 1 minus sine squared of x. So we can replace the red 1 minus sine squared of x with cosine squared of x. That's as simple as we can get it. Write an expression for each of the following in terms of the given function. We have to get secant in terms of cotangent. So here's a function, here's an identity that I think best represent this. Secant squared of theta equals tangent squared of theta plus 1. If you square root both sides, you get secant by itself. And then if you change tangent to cotangent using the reciprocal identity, also recognize that we're going to have to add 1 to this. 1 as a fraction is cotangent over cotangent. I'm doing that so I have common denominators. Once you have common denominators, you add the tops, leave the bottoms the same. We have a square root of a fraction, which we cannot have a square root of a fraction. It's not proper to leave it that way. You can square root the top and square root the bottom separately. The top is not a perfect square. It stays the same. The bottom is a perfect square. Its square root is cotangent. So we finished the problem. We got secant by itself. And on the right side, the only trig functions we're using is cotangent. 18. I think the Pythagorean identity would be the best place to start for this. Sine squared of theta is the same as 1 over cosecant squared of theta. So now we have the right trig functions. We just have to get cosecant by itself. If you subtract the cosine from both sides, cosine squared from both sides, and if you multiply both sides by cosecant squared, trying to get cosecant by itself, then divide both sides by 1 minus cosine squared of theta, square root both sides. We would be finished, but once again we have a radical in which there's a fraction inside of it. You can't have that. So we can rewrite it as square root of the top, square root of 1 is 1, divided by the square root of the bottom. The bottom is not a perfect square, so you have to rationalize it. It means you have to get rid of the radical. So you multiply the top and bottom by the square root of 1 minus cosine squared of theta, and you get the following.